Great. Hello, Trevor.
Hi.
It was very interesting presentation you delivered this morning.
Thank you very much.
Really exciting indeed. But before we'll start to talk about your work with DeepMind, can you tell us about how initially you get involved into artificial intelligence sphere and intersection with healthcare?
Yeah, absolutely. So my original background was in computational astrophysics. I was running simulations of the early universe, trying to understand better how early star formation occurred. And when I came to the end of my PhD, I was looking for roles with a more impact in the real world. And I came across DeepMind and Demis, Shane and Mustafa and their mission to sort of apply AI to the real world, and I sort of was very excited to join on board that mission. So I joined 6.5 years ago, and ever since I've worked on the intersection between taking fundamental research algorithms and applying them to real world problems.
Mm-hmm. Great, interesting. Well, maybe the first question about DeepMind. How DeepMind Health is working with NHS, and actually what is the long-term goal?
So firstly, it's fantastic to have the opportunity to work in such deep collaboration with our NHS partners. We do so both on the research side and on the direct care side with our mobile application streams. And what we want to do is we want to be clinician-led and patient-led as to a definition of the problems that they're dealing with, and then to work with them to understand whether deep learning or AI is the right solution to that specific problem. Our aims are to improve patient outcomes over the long term, and to resolve some of the challenges in scaling healthcare to the new world problems we're facing. And in any way that we can help provide algorithms and systems that enable clinicians to better do their jobs without challenges such as burnout, we're excited to be engaged in those types of projects.
Okay, great, very interesting. And what is your role in DeepMind in particular?
Yeah, so my role is as product manager, but I'm also the research lead for the DeepMind Health team. That entails essentially building and growing the research team on the health side, and also building the collaborations and partnerships that enable us to work on challenging, valuable projects in healthcare, such as our partnership with Moorfields Eye Hospital and our partnerships with University College London Hospital and the number of other partners we work in healthcare.
I see, very interesting. And in your presentation, you mentioned that you are currently focused on applying artificial intelligence for eye scans analysis. So can you tell us more about this? Because really very interesting, significant, specific niche.
Yeah, so we were approached by Piers Keane after he read a Wired article where Mustafa had stated that we were interested in healthcare. And Piers came to us and explained the problem space where there's this growing prevalence and growing demand for age-related macular degeneration and other types of eye diseases, and the way that Moorfields is trying to innovate to deal with the increased pressures of the increased numbers of people coming to them with potential eye diseases. And he also described to us the way that you can detect these types of eye diseases from these OCT scans. And we were really interested because it was a large 3D complex data set. There was a number of different challenges, including segmentation and the classification and the referral decision. And we felt like it was a very tangible project for us to showcase how not just that deep learning could work on this problem, but exactly how to tackle that problem in defining the use case, in defining the clinically relevant metric, and in evaluating it appropriately on the specific task at hand, which was when a patient first is referred to Moorfields Eye Hospital and they need to be triaged as to whether they need to be seen urgently within a few days, or whether they can be seen within a few weeks or months. How can you optimize that flow such that the urgent patients are caught as quickly as possible?
Okay, and what are the main challenges you're facing in your work and your research?
Yeah, I think there are a number of really interesting challenges. I think the first of which is the access to the right type of data for the problem at hand. And you know, a great example here is Moorfields had a very large retrospective data set of over 1 million eye scans. When we started diving down into the specific problem that we were resolving, which is this first OCT on first entry, that obviously massively reduces the size of the data set available. And so how do you then train an algorithm on these much smaller data sets? And one of the ways we overcame that with this two-stage architecture, where we train a segmentation network followed by a classification network. And that enables us to train on lower number of images and labeled images, critically the label images, than it would have needed if we trained an end-to-end network.
Okay, makes sense. And the other related to this question, I'm quite sure that you also conduct some research related with eyes in particular, maybe early stage diagnostic of some other diseases.
So I think you're specifically referring to a recent paper from our sister team in the Google Brain team, which has learnt to predict cardiovascular disease risk from the fundus photos. And so this is a really interesting outcome that shows that potentially these types of non-invasive analysis of a patient could lead to potentially other interesting predictions. And in this case, they found that, yeah, you were able to, quite highly accurate predict whether this patient is at high risk of cardiovascular disease or not. The OCT, as Piers Keen tells me, it's the only way to non-invasively understand the brain, to see the brain. It's the only way that you see the nerves that connect to the brain. And so there are a number of questions over whether the OCT scan can be used as an indicator for Alzheimer's or dementia or other types of diseases. And I think there are a number of groups that are looking into whether this might be possible to detect. One of the things we are doing is providing Pierce and Moorfields with access to the API that can run our Octane algorithm, our ophthalmology algorithm. This will enable them to have access to the ability to segment the OCTs and get the diagnosis predictions so that they can use that for further clinical research that they're interested in that not necessarily DeepMind is involved in.
Yes, I see. Yes, make a lot of sense. Well, since we are today at Deep Learning conference, can you tell us how in particular you're applying deep learning techniques to help with your research, with your work?
So we spend a large amount of time talking to very interesting groups of people around problems that they would like to resolve. And there is a lot of data in the world and a lot of problems that could be solved with that data that don't necessarily require deep learning as the solution. And so we spend a good deal of time looking at these problems and trying to decide which one is the appropriate problem for deep learning to be the best potential solution to, rather than more traditional machine learning methods or even just statistical methods. Yeah. So we're looking for really complex data that's high dimensional. Perhaps there's a lot of sequentiality to it, but essentially the way of building a number of heuristic features essentially becomes limiting in time, and therefore we're looking at how can we use deep learning to overcome the fact that you can't try all the different heuristic features against each other. Imaging is obviously a place where deep learning has shown huge potential and success in natural images, and therefore it makes sense for it to work well on medical images. And secondly, deep learning has worked particularly well on understanding sequential prediction problems because it can take the context of the history into account in a more concise way. And so we're also looking at how do we predict potentially adverse events or patient deterioration in sequential essential electronic health records.
Okay, interesting. Well, let's switch a little bit the topic. So nowadays we hear a lot about AI for social good. Can you tell us how in DeepMind you are using artificial intelligence for benefit of all of us?
Absolutely. So DeepMind has two missions. The first mission is to solve intelligence, and that's where the work on Atari and AlphaGo and AlphaGo Zero is making groundbreaking discoveries into understanding how can we make advances towards artificial general intelligence. And the second mission is to then apply this to solve the world's problems. And so we're working on a range of different areas where we believe there are complex, systemic, stuck, difficult structures. Those include energy and healthcare. And so, 3 years ago, we started up healthcare with the aim to understand where deep learning could have a positive impact on improving patients' lives and outcomes. And so it's been a real pleasure and privilege to be working on that from the initiation of that project. And our aim is to move towards a way where the in a machine learning context, the training label is not necessarily the diagnosis made at that point, but it is the long-term outcome that the patient has. And if we can get to that stage, then we'll be able to develop algorithms and systems that are able to make predictions based on the best outcome for that patient over a long time period. And that, to me, improving patients' lives through that, there's no sort of better mission to be on from a societal impact point of view.
Okay, great. In your opinion, how artificial intelligence can change healthcare, maybe healthcare specifically in the UK, healthcare system in the UK next years, not decades?
There are a number of areas where deep learning and AI is already showing in the research space that it's able to resolve complex problems. The Moorfields Eye project that we've been working on is one of those.
Yes.
And I think for that case, the sort of two real problems we're overcoming, should we get the algorithm through the clinical evaluation and regulatory approvals that are required. And those are, one, the sort of growing demand for these types of diagnostics in the NHS and the growing prevalence of the disease in patients. And so the NHS is struggling to keep up with the requests for resources from this group. And the second one is that the algorithm performs at the same level as an expert ophthalmologist with 20 plus years experience at Moorfields Eye Hospital, which is one of the world's best eye hospitals. And this enables accessibility to that level of expertise throughout the country. You don't need to be lucky enough to be sent to Moorfields Eye Hospital to get this world-class diagnosis and referral decision. You can get it wherever. So we're resolving the challenges of increased demand and accessibility.
Okay, makes sense. The other question. UK industrial strategy recognizes artificial intelligence industry, development of artificial intelligence industry as #1 national priority. And at the same time, problem of aging population is second within 4 national challenges. So my question is, and more of it, there are 10 million of people in UK already on retirement. So the question is, how in DeepMind you are working, let's say, on that front? Maybe let's say, if to be more precise, how you're applying AI techniques for preventive medicine for elderly people to extend their healthy longevity?
Yeah, no, that's an absolutely fantastic question. I think with the Moorfields project, we're working on age-related macular degeneration. This is much more common in elderly people. And so if we're able to predict the likelihood of somebody getting age-related macular degeneration in the future, then we could suggest taking preventative measures to help reduce the number of patients getting age-related macular degeneration in the future. We're also working as part of a consortium with Cancer Research UK, Imperial College London, and Royal Surrey on breast cancer screening. Obviously, this is again an increasing problem as part of an aging population, and the screening program is dedicated to screening patients every 3 years. And there's a rising number of patients and a decreasing number of radiologists, so there's an opportunity there for AI to help support that program. And finally, with acute kidney injury, not only if you can help avoid acute kidney injury with the STREAMS application or with some deep learning that we develop, then not only are you preventing that specific injury, but if a patient suffers from acute kidney injury when they're younger, they are much more likely to suffer from chronic kidney disease or other types of kidney-related diseases when they're older. So by preventing these types of events when people are younger, you're increasing their health when they're older.
Yes. Okay. Very interesting. Okay, Trevor, what's for you next? What are your plans?
Yeah. So well, we're absolutely delighted with the progress we've been able to make on showcasing how deep learning can work well on these specific tasks, such as triaging for OCT scans, segmentation for radiotherapy planning, and looking into mammography as well. Our next plans are, as they always have been, is how do we get these out of research mode and into clinical practice such that they're having a real patient impact. We've designed these research programs from the ground up to be focused very much on specific clinical problems, with the idea that we are training algorithms that will be able to get into clinical practice and have that positive impact in a nearer term than, say, if we just focus on diagnosis of OCT scans rather than specifically triage of OCT scans. So the next steps are to run clinical evaluations and trials of these algorithms to showcase their efficacy, to get them through the regulatory approvals and get them signed off from a safety perspective, and to see them in action really having an impact on patients' lives.
Great, thank you. The last question, where can we find you? I mean, Twitter, LinkedIn, maybe papers? Yeah, so
we're committed to publishing all of our work, and so you can find us in Nature Medicine for our ophthalmology work. You can find us on Archive for some of our radiotherapy work and some of our probabilistic segmentation work. Feel free to email me on trevor@deepmind.com, and I'm on Twitter at TrevorBack.
Great, very interesting. Thank you.
Thank you for your time.